All right, we are on lesson 7, residuals. So I'm on my Google Drive, and I'm going to import the libraries. Then remember, I need to import my data. So you click on this folder, go to your G drive. This is 2 variable statistics. And then we are on residuals, not the quiz. And I'm going to get out the lesson 7 XLS file and then just put in the path there. Import it. And we're going to look at what residuals are. So residuals tell you from the line of best fit how far above or below is each point. So that's the residual value. Obviously, not all the points are going to be on the line. A few points might be, or will be really close to the line, but not all the points are on the line. So what you're going to do in this first activity is just draw vertically from the line of best fit a line to the residual, estimate about how far off it is. So write down all your estimates, like this first point, I would estimate it to be negative 0.29, and then so on. Now, obviously, that's the exact number. Um, so you can fill in those values and then add them up. Now, spoiler alert, when you add those all up, you're actually going to get 0, because remember, it's line of best fit. So the sum of the residuals is going to be 0. So on here, what we're going to do is use the table to estimate the line of best fit. Now, I'm also going to show you, so what you would do here, here's the actual values that were in there. You're going to put the strength values in. So you're going to go, this Y value is 1.05 minus 0.82 times this number, and then have the students fill those in. And then for the residual, you do the actual value minus the expected. Now that said, we're going to use Python to make that go way quicker. So there is our line of best fit and our points. But here, I'm going to fit this model. Then if you notice, my intercept is 1.04, and then my slope is negative because the line goes down. And then what we're going to do is I'm going to get my predicted value. So if I go model 1, which I use when I fit the ordinary least square models of the porosity, which was my x variable, to the strength, which was my y variable, and then there are my values. So you could just put in order, like maybe put that as 0.778, and then just fill that down. Secondly, what I can do is find the residuals. So if you just put model1.resid, it lists all your residual values. So 2 or 3 decibels is fine here to list those. Then you can actually do the sum of the residuals if you were to find that. So this is good activity on, plugging in numbers, finding Y values, and then finding residuals, and then find the sum. If you just add all of the residual values, you should get around 0. And then here, that's how you can do that a little bit quicker with Python. Now what I'm going to do is you're going to make a residual versus fit plot. So if the porosity is 0.33, you go up the residuals 0.06, which would be about right here, and you just plot each of these residuals. So just make a scatter plot of them. Now what I'm going to do is show you again how to plot that with Python. So Python plots the residuals versus fits pretty easily. So you just put SNS resid plot with X being porosity and Y is strength, and then show it. So this will just put on here are the X values, and then this is how far above or below the line from the line of best fit the value is. Now, oftentimes you're going to learn in higher statistics classes how to analyze these residuals and make sure that there's a random scattering of the points versus the residual showing patterns. That's something to look forward to in later classes. So on here now, what you're going to do is practice finding the equation for the line of best fit, finding the residuals, plotting the residuals, and using a code to do so. And then additionally, you will be doing a check for understanding where you'll practice that one more time. Again, make sure students are actually plugging in the numbers to find the predicted values and then also finding the residuals by hand and then plotting those and then using the technology to do so that they understand where the predicted values come from and where the residual values come from.